So all we're going to do with this lesson, we're just going to define some terminology, which again I have to ask you for the purposes of the curriculum, right? But it does lay a good foundation of like if we start talking in class, we're going to use this terminology. You guys have to know what we're talking about, like as we move through, right? So this at least gives you like, we've talked about some of these, okay? So a term, okay? A term is going to be what we're going to define as a let's go in black today. A mathematical expression, okay, which has symbols and numbers. Okay, and then a couple examples would be like, I don't know, 7x squared, 6x, or I don't know, 3xy. Okay, that'd be a term. Okay, that's like the whole package. You can see in the bottom here. Okay, I'll highlight this, and we'll define them. We've discussed coefficients already in the linear stuff, right? Variables are the letters. Okay, so we'll just define these now, okay? So the symbol, or sorry, the coefficient is the numerical part of the term, okay? That's basically, you could write that in any way you want. Coefficient is the numerical okay? Then the variable is going to be the symbol part, okay? Okay. Now here's the one maybe we haven't seen before, the degree, okay? Because most of what you guys have done have been lines. So the degree of the equations that you have been working with has been 1, okay? Lines are very kind of linear, plain, right? There's not a lot going on, okay? So their degree is just 1, okay? You can start to see here the degree of a term. This one's a little bit longer, okay? Degree oh, sorry, Sammy. Yeah, it's underneath here. Yeah, there you go. Okay. So if we look here, I'll give you a couple examples and we can fill out the table. Okay. So an example would be if I gave you, let's say, 5x squared y cubed, the degree would be, what does it say? The degree of a term is the number of variables multiplied together. I see 2 x's and I see 2 y's multiplied together.
How do you see 2 x's and 2 y's?
Oh, okay. Also, yeah, okay. So, yeah, I'm speaking too far ahead. Okay, one sec. So another way to write this is 5 times x times y times.
3 y's done, not 2?
Yeah.
You said 2.
Oh, did I? Sorry.
Yeah, that's
2 x's and 3 y's. Sorry. Okay, so I see 5 variables. So the degree is going to be 5. Right? One for each of these. Is that okay? Yeah, Coco.
How did you know there's five? There's five variables?
There's 5 variables, yeah. So this, you're basically adding the 2 numbers that are here. Okay, because there's 2 x's and 3 y's. That's what it's saying. Okay. So its degree is going to be 5 because there's 5 variables there. 2 letters or 2 variables, but then there are 5 of them. Okay. So we'll run through some practice ones down here in the table, okay? So the coefficient, remember what the coefficient is? It's just the number portion. So what's the coefficient in the first one here? 2. Okay. What about, let's just do all the coefficients first. Okay. In the second one, I have a coefficient out front. It's the number. It's -4. Okay. And remember what all these are. Just the big picture here. These are all terms. Okay, that'll mean more once we start doing some things here, okay? But just keep that in mind. This is the big picture. Big picture is terms, and then terms are sub-broken into coefficients, variables, and then each of them has a degree. That's kind of what we're doing, okay? The coefficient in the next one's 5. This one's kind of tricky, but what if you don't ever see anything in front of a letter or a variable? What does that imply? That's 1. Okay, so there's a 1 out front, this one. And then the last one, what's the coefficient? So what we call like kind of a, this one's just a constant. It's called a constant because you can't multiply it by anything because there's no variable there. Okay, so it's always going to be -1. So it's called constant, okay? But it is still a term. Okay? That make sense? I'll try to, at the end of this, I'll try to draw you a picture, like kind of a, it'd be like a family tree. You can see it kind of spaced out, and you can see how everything kind of flows into each other. I'll try to do that at the end, okay? Remind me if I forget. I think it's useful. Okay? So now we can look at the variable portion. What's the variable in the first one? Yeah, just x, right? Not x cubed, it's just x. Okay? Okay? What are the variables in the second one? You got 2 of them. X, y. Okay? And the third one, it's a. The fourth one, it's going to be t. And then the last one, is there? There's no letter there, it's no variable. Okay? So it's not applicable. Okay? And here comes the fun one. What's the degree in this one? In the first one? How many variables are there? Number-wise? 3. Okay? How many variables in the second one? 7. Okay, how many? And then 1 in that one. What about this one? The fourth one down would be 6, right? Because there's 6 t's. And then the last one, there are no variables, so there cannot be a degree.
So it's not still 1.
No, because there's no variable. Yeah, Wesley.
If there was a function like that, like rather than a 0 or not available?
Oh, not available. Yeah. Okay.
So you wouldn't write 1.
You could. Yeah, sorry. Yeah, you could. No variables. Are you talking about this one?
No, the one that you wrote, the degree,
Yeah.
0, you can't write 1.
No, it's not 1. There's no variable. If you write that it is 1, like remember the degree is if we look at,
It's only applicable to the variable.
yeah, it's counting the number of variables basically. Okay, so if there's no variable, it can't have a degree. Okay. Okay. Now, this stuff is not anything new. Okay, it looks a little bit new because we started throwing weird things in here like the x squareds, which you haven't seen yet. But we've already done this, right? This is like we have apples, we have bananas, and we have oranges. This is where collecting like terms, the terminology for that comes from. Okay? You can add things that have x squared and x squared. You can add things that are x's and x's, and you can just add numbers and numbers, right? And you can collect them and then write a new statement underneath that has 3 terms instead of 6. Okay? So right here, that's kind of important too to make that distinction. I see 1, 2, 3, 4, 5, 6 terms, right? The thing with simplifying is you make it, we're able in this particular question to take 6 terms, we're going to turn it into 3 by collecting like terms. That's what it means by simplifying. Okay? So, you can, your first step, if this helps you, and it sometimes helps me for the pure reason that like you can make a sign error pretty quickly. Okay, I always just rewrite this thing, but I group everything together that are like, and then I do the math, right? So for instance, I'm gonna go x squared minus 3x squared. Okay, I'm taking the whole piece that's there, and I'm just shuffling it over. Okay, and then I'm gonna go minus 3x plus 5x plus 2 plus 1. I don't have to worry about the signs changing at all because I'm not bringing it to the other side of an equal sign. I'm just technically moving everything around on one side because I don't have to worry about the sign changing. I can just move them around. Okay. Now you can just collect the like terms or do the math on the like terms, right? Because you've grouped them. So you're going to have 1x squared minus 3x squared. That's going to be negative 2x squared. Negative 3 plus 5 is going to be plus 2x. And then the last one's going to be plus 3. Does anybody have any issues? Okay, just understanding what the terms are, and now we can actually provide context around what it means to collect like terms, right? Just to simplify. Yeah, I read it.
We're not factoring through the rest of the statement.
Not yet, not yet. We're going to do that in 2 and 3, 4, 5, 6. You're going to do lots of factoring. Don't worry, buddy. Lots of factoring to do. Okay? Are we okay? So again, we're just going to collect like terms here, okay? But this time they're starting to throw, this is where sign errors are going to start to come in, okay? Remember what I tried to show you guys, like I treated these like jail bars, okay? To get rid of the jail bars, you multiply in. Okay, it doesn't matter if it's a 1, it doesn't matter if it's like another term. To get rid of the jail bars, you're going to multiply in. Okay, so just to rewrite this, okay, I'm going to do this one step at a time here. 3x squared doesn't really have anything fancy with it. Positive 1 multiplied in is going to be minus 4x. Now here's where it makes a difference. I have a minus sign multiplied against another minus sign. So these two here this is where it's very easy to make a sign error. You got 2 negatives back to back. Okay, has to become positive. Okay, plus 5. And then the minus always dominates the plus sign, right? So if you were to multiply negative 1 in, it's going to make whatever's on the inside negative. So minus 2x squared. Is that okay? Now you can just collect them. Nothing else to go on here. So you can rewrite the thing again. And you may or may not need to do this in as many steps as I am. Okay? But it's easy to make an error with a sign or something. All right? So 3x squared minus 2x squared minus 4x plus 3x plus 5. All I've done is shuffled all the terms around. Okay? 3x squared minus 2x squared is going to be x squared. Negative 4 plus 3 is going to be negative x plus 5. Okay, that's it. This lays the groundwork for what we're going to do in like lesson 2 and onward, right? You're going to have to be able to get things to look like this in order to work with them. Okay. Next one. Okay, you got a negative 1 here. I'm going to deal with that. So positive 1 out front of this one, so that's not really that big of a deal, right? The first one you could basically just multiply in. You're going to get rid of those brackets, right? So it's going to be 9x squared minus 4xy minus y. Okay? Then the negative 1's going to go into these guys. So they're all going to change signs. Minus 6y squared plus 3xy minus 10x squared. Okay? Then you're just going to regroup or collect the like terms. 9x squared minus 10x squared. Okay, and the other thing is, does everybody see what I'm kind of doing with the degrees of each term? 2, 1, 0. This is what we call, I try to always write these things. I don't think it's necessarily wrong to not, but I think it's really good practice to always write it in what we're going to call descending order.
Is that just standard one quadratic?
Yeah. I think, yeah. It just makes your life more difficult if you don't write it this way. But does everybody see what I mean by descending? I have a degree 2, I have a degree 1, and then I have a degree 0. Each term just starts counting down. You always go with the highest degree down to the lowest. Right? Is that okay? It's just good practice. I maybe skipped over that. But that's what I'm doing. You can notice I do that every time. Right? Same thing here. I always group the biggest degree on the left, then the next one, the next one, next one, as you start going down. Okay? Okay. Sometimes I like to, as I group them, I like to kind of scratch them out so that I know I've got them. That's another tip for you guys, so you don't forget any. Okay? There you go. Okay. I'm going to go to the next highest. I'm going to go minus 6y squared. Okay? You can kind of scratch it out because you know you've done with it. You go minus 4xy plus 3xy minus y. Okay, they can group all the, or collect them, or just do the addition. So 9 minus 10 is going to be negative x squared minus 6y squared. Negative 4 plus 3 is going to be plus, so minus. Okay. Everybody see that okay? Okay, setting these up is kind of important. You'll see later. Okay. It's always like, if you can make it look nicer, it'll make your life easier. Okay, you just kind of collect everything. That's kind of the first step. Okay.
Wait.
Yeah, mate.
For x and y, would the degree be 1 or 2?
2, I think.
2. Would it be 2? Is it 2 variables?
2 variables. There's a 1 on each of them. Okay. Is that okay? This one here's okay. So this one gets a bit interesting. This is starting to kick it up a little bit of a notch here. Okay. Again, same thing. This was kind of alluding. This I said this earlier, but I didn't have like any context to it. I just said it as words. Okay. This is the context. You have a term multiplied by another term. Okay. I don't know if we've done this yet because this is all like we've only done linear, but same rule applies. To get rid of the jail bars, you have to multiply in to both things. Okay. Now here's the catch. When you multiply variables together, you have to add the exponents that are on each of them. For instance, when I do the first one here, you also have the coefficients to multiply to. Okay, so with this one, when you multiply, I'll do this aside here, okay? When you multiply 9x multiplied by 3x, you're going to get 18x squared. Okay? The 9 times 3, sorry, it's not even close to 18, it's 27. Okay? 9 times 3 turns into 27. Okay, and the second piece of this is x plus x turns into x squared. You're not adding, but you're adding the exponent on each of them, which in this case is 1. So 1 plus 1 gives you the 2. Okay? Is that okay? So the next line here, remember that's kind of an aside. You're going to use that 2,000 times in this course. Okay, so we're just going to go, we've already done the math on this one. It's 27x squared. That's from this. And then the second one is going to be minus 45x. Okay, and then I have a negative 1x. I'm going to put that into both. So it's going to be minus 2x squared minus 3x. And then I have the minus 1 here. There's no variable, so this one's nice. So minus 7x squared plus 2x. Does anybody have any like major issues with anything I've done there? Okay, we really have 3 things going on now. Okay, you have signs to keep track of, you have coefficients to keep track of, and you have variables to keep track of. They are all separate. Okay, if you think of them separately, you multiply signs with signs. That takes care of double negatives, things like that. You multiply numbers together like you normally would, and you multiply variables together, okay, which is that's a new thing for you. But if you treat them as 3 distinct separate things, all of a sudden these things start making sense instead of like, how did I get there, okay? And now we can just collect the like terms. Okay, so I'm just going to group. So I'm going to get 27x squared minus 2x squared minus 7x squared. Okay, what I like to do is I go find all the x squared terms. I write them first, and then I can scratch them out so that I know I've got them. And then minus 45x minus 3x plus 2x. Right? Now you just do the math. 27 minus 7 is going to be 20. Minus another 2 is 18. 18x squared. Okay. Now we're at negative 45. Minus 3 is going to be negative 48. Plus 2 is going to be negative 46x. And that's it. I don't see anything else to add or subtract. I've dealt with everything. So you've taken something. What's nice about this, and remember to keep a big picture in mind. You've taken something that looks like this, okay? And just by collecting like terms, you've turned it into something that looks like this. That looks a little bit nicer than the top one, I think. Okay? Any questions? Doing okay so far? Okay? Just kicking it up another notch. Same rules apply. Okay? I'm going to show you. I'm going to show you 3 different ways, okay? And then I'll zoom through the rest of it, okay, for the purposes of time. You can pick whatever way you want to do this.
Did you say 3 different ways?
3 different ways, okay? I have been, since we've started doing this, I've been using what we call like the rainbow method or whatever, okay? By that I mean we take this one, we multiply it by this one. Then we take it again, we multiply it by the second term. Okay, but we haven't dealt with this one yet. So it also needs to multiply against the first one, multiply against the last one. This is my, like, I've done this a million times. Like, this is my preferred method. It's the fastest, I think. I always, to this day, still draw the hoops on top to make sure they don't miss anything. Okay. It's the fastest, I would think. But it is also probably the easiest to make a sign error or something silly, right? Which is going to give you the wrong answer. Yeah? You have a question or no? No? Okay. Right? So with this, if I follow the lines, that's all you're doing. You're following the little curves, right? You're going 7x times 5x. That's going to be 35x squared. Then I'm going to do the second arch from here to here, 7x times 1 plus 7x. Then I've dealt with everything there is to deal with the first term, the 7x. I have to deal with the second one now, the negative 2. So then I'm going to go negative 2 times 5x is going to be minus 10x. And negative 2 times 1 is going to be negative 2. Now what's nice about doing it in that order is you will get, it's basically in descending order already. All you have to do is collect the 2 terms in the middle and you're good to go. Can you guys see that? Sorry, I maybe made that worse. Green on red is not probably a good idea. Okay, so you just collect those 2 terms in the middle and then you're done. So you get 35x squared minus 3x minus 2. Okay, this can be method 1. Method 2 is just kind of, it's an acronym, okay, that allows you guys to keep track and make sure that you've done each of the things, right? So it's what we call FOIL. Okay, FOIL stands for, I'm going to erase the bars here, okay? FOIL stands for firsts, outers, inners, lasts. Okay? So by that I mean, if you look at this, firsts means firsts. Okay? It's a little hard for me to do in all different colors, but the next one we'll do in green. Outers, outsides. Okay? Inners. Okay, it's starting to become a bit more self-explanatory. Are the 2 on the inside. Okay? And the lasts are the lasts. Okay? So all you do is you follow in this order. You go, okay, well the firsts are going to be 7x times 5x. The outers are going to be the 7x times 1. The inners are going to be negative 2 times 5x. And the lasts are going to be negative 2 plus, multiplied against 1. Okay, then you can do the math on each of them. So 7x times 5x is going to be 35x squared. Then you're going to get 7x. You're going to get negative 10x for this one. And then minus 2. And then you can collect the terms. Right? I see two terms that are similar in the middle there. Right? So this whole thing's going to turn into 35x squared minus 3x minus 2. Same answer. Okay. That's your second way. I'll show you one more. Okay. The last one I like for the purposes of it's got a dual purpose. Okay, so you're able to do it with this, but then you're also able to apply it to factoring when we start doing factoring. That's why I like this one. Okay, so this one's like, this is a good one to remember. Okay, it's not what goes in the box, but okay. Yeah, you know what? You can use the box here. Let's use the box. Okay, you can scratch out the word remember. Okay. Yeah, buddy. Okay, yeah, yeah. It's blowing right on you, which is kind of, probably feels colder for you than it does me. Okay, so scratch out the word remember, okay? And we'll actually use the box here. Don't scratch out the box though, okay? Here's what we're gonna do. I want you guys to draw like, kind of like, well, just draw what I draw. This is what we're gonna call the table method, okay? You can put, I can't really put a table, a title on, okay? Put it down here. Okay, this will be your third method. You can choose any of these three, and I will prove to you that they're all the same. Okay, they're all multiplying, but here's what happens. Okay, I like this method. I like it because I never got shown it, and then when I saw it, I was like, okay, that's pretty cool. Okay, what you can do is you take each of the pieces. You have two pieces here, two terms. Okay, you go 7x minus 2. Okay, and down the other side, you're going to go 5x and plus 1. Okay, now you're just going to fill in the middle of the box. And you're going to do that by multiplying. So anytime you get a number on the inside of here, you have better multiplied the two pieces that kind of intersected there. Okay, so for the first one, you do 7x times 5x. It's 35x squared. If I'm looking at 5x and negative 2, I'm going to multiply to fill in the box that they intersect with. So it's going to be negative 10x. Okay. Then positive 1 times 7x is going to be 7x. And positive 1 times negative 2 is going to be negative 2. Then all you have to do, collect the two terms that are in the middle. That's it. I don't care what you do. Okay? It's almost like substitution elimination. I don't care which one you pick. You just kind of care about the answer. Okay? Is that okay? You guys want to try the number 6? Try number 6 on your own. Pick a method, and then we can unanimously come up with one method to do as a class. Okay, I'll bounce around here for a minute, and then I'll I'll go through the last three pretty quick, and then I'll give you guys some work, okay? Okay. I'm just gonna, you guys can choose your method. Okay. You can confirm with your method if you've gotten the right answer. Okay. Shouldn't really matter too much here. What I'll do is I'll try to get through these ones pretty quick. I will do the table method for this one, just because I think it's also it's a little bit easier. I don't know. Doesn't matter really. So here's what I'm gonna do: 2x times 3x, 2x times minus 5. Okay, so I'm gonna get 6x squared minus 10x. Then I got to do the bottom. 4 times 3x, 4 times negative 5. That's going to be plus 12x minus 20. Does the black and red help? You guys can see where each number comes from, sort of thing. Okay. Then all you do is collect the like terms, and then you're done. 6x squared plus 2x minus 20. Okay. The plus 2x comes from the addition of these two guys. Okay. Here's a trick. Okay, what did I say? This is a useful skill too. What did I say earlier when I said if you had something like x, let's say x cubed, what does that mean? Okay, we kind of did this earlier. If you could rewrite that, it would turn into x times x times x, correct? Because there's 3 of them. Well, just because there's more stuff on the inside does not change what's going on. You're totally allowed to write this thing as 3x minus 4 times 3x minus 4. There's 2 of them. Doesn't matter if there's 10. You write it 10 times and multiply it 10 times. Doesn't matter. Okay, so I'm going to do it again. 9x squared minus 12x. Okay, that'll be those ones, and then the red will be the bottom. It's minus 12x plus 16. Okay, and then you can collect the like terms. 9x squared minus 24x plus 16. Okay, one more. Again, it doesn't matter. I'm going to show you the table method, but it doesn't matter if you do this. The problem is FOIL's going to break down for you here, right? You've run out. FOIL is really only for when you have 2 times, like FOIL only really works for these guys, okay?
And you have
2 binomials. Yeah, I haven't gotten into that terminology yet, but yeah, 2 binomials. Okay, when you have 2 pieces like that look like that, you can only use FOIL. So now we've broken the FOIL method. Okay, so but table or the rainbow method will always work, right? You just got to count. Okay. What I'll do for this one though, because I think the table's kind of cool. You're just going to add another row to your table. Okay, so what you can do, row or column, doesn't matter. You can make an elongated rectangle like this, right? Okay. You fill in, your job is to fill in the middle. You're going to go x minus 1 on across the top, x squared negative x plus 1. Fill in the middles with multiplication. That's it. I can make this as complicated as I want. Doesn't change the principle. The only thing it does is it just opens the door for a little sign error for you guys, right? Which isn't the point of the question. The point is, can you apply FOIL, the distribution method or the table, right? So this would probably be as big as I'd ever give you, because it's just starting to get, what's the point if I give you something where you have a table with like 30 entries? It's just stupid, right? That doesn't make any sense. Okay, so all you do is just multiply, right? X times x, what's the, you got an exponent of 1 there, so that's going to go to x cubed. X times negative 1 is negative x squared. Negative x squared. Now careful with this one. Negative times a negative plus x minus 1. You rewrite that. X cubed minus 2x squared plus 2x minus 1. Done. Notice what I did. 3, 2, 1, 0 in the degrees. 3, 2, 1, 0. Descending order. Okay, that's important. Okay. I'll leave you the challenge. Okay. I will post a solution to it. Okay. But basically, what does this mean? I'll set it up for you. What did I say here? It doesn't matter what the number is. Okay. I'll post a solution to that. It'll be the lesson, but I'll do the work here. Okay.